Some Rust language features can be used in multiple different ways, and when you first come across a less common use case, it can be a bit confusing. This happened to me with the Turbofish syntax, where at the start I'd only been using it with methods like collect and parse. Here you can see the collect method of the iterator trait is defined to take a generic type parameter b, which is used to specify the return type of the method. So, for example, you can create an iterator over an array, double the values using map, then convert the iterator back to a collection by calling its collect method. In this case, the collection type is specified as vec i32 using the Turbofish syntax applied to the collect method. Note that it's the collection type that's unknown and must be specified. Alternative syntax that uses an underscore in place of the element type is also possible, because that type can be inferred from the type of the array elements. Also note that in many cases the Turbofish syntax is optional and can be avoided where the type is specified elsewhere. The parse method of the string slice type is defined to take a generic type parameter f, which is used to specify the return type of the method. This parse method is useful when you want to convert textual user input or file input into its natural type. Here, the parse target type is specified as i32 using the Turbofish syntax, again applied after the method name. And again, the Turbofish is optional. The first time I needed the Turbofish for something other than a method resolution, it took me a moment to realize what was going on. So I made a note in my 1x Rust noob diary to investigate the various other ways in which the Turbofish syntax can be used. Here's what I came up with. Firstly, associated functions where a generic type parameter is specified on the type, not the function. For example, the vec type and its associated new function. The generic type parameter is on the vec, so calling vec new with Turbofish syntax looks like this, or avoiding the Turbofish like this. Next, there are trait methods where a generic type parameter is specified on the trait, not the method. For example, the into trait and its into method. We can create a new type called number that wraps an i32 and can be created from an i32 by implementing into number for the i32 type. The generic type parameter is on the into trait, so calling the into method with Turbofish syntax looks like this. But alternatives include this and this. Note in that last case, where method call syntax is used, there's no longer the option to use the Turbofish, since the generic parameter is tied to the into trait, not the into method. Generic const parameters are another Turbofish use case. You can see from the standard library implementation of the method first chunk for the slice type that generic const parameter syntax is a mix of generic type parameter syntax and const declaration syntax. The method first chunk will return an option for a reference to an array representing the first n elements of a slice or array, where n is specified by the generic const parameter. So here, aref will be a reference to an array containing the first two elements of SL. An alternative form of this, without Turbofish syntax, is this. Const generics can also be used on types. The Rust primitive array type already has a generic const parameter for its size. But we can create a wrapper for an array to demonstrate the use of the Turbofish. The zero array struct takes a generic const parameter, which we must then supply when creating a new instance. Standalone generic functions are one of the simpler use cases for generics and the Turbofish syntax. This particular example demonstrating the sizeOf function is interesting though, as the Turbofish syntax is not optional. The compiler cannot infer a type for the generic parameter, and there's no other way to specify the type. Lastly, you can use Turbofish syntax with an enum variant to specify the generic type parameters of the enum. Here, we're specifying the generic types for result as part of an expression that uses the OK variant, and also specifying the generic type for option as part of an expression that uses the none variant. And, as in previous examples, you can also avoid Turbofish syntax, in this case specifying the full enum type for the bound variable. Thanks for watching, and please like and subscribe so that you don't miss out on the next video, which is on the subject of closures.